Hello everyone, I am Professor Hungwei Li from the Department of Applied Psychology at Xuanchuang University, and I am also the project leader of our university's second phase Digital Humanities Innovation Talent Cultivation Program. Although my academic expertise lies in cognitive neuroscience, my Atayal heritage and passion for programming and technology since my student years have driven me to focus on integrating indigenous cultural revitalization with cutting-edge technology in recent years. This dedication led to the proposal of the Digital Indigenous Culture Revival and Industry Development Project. In this video, I will share an introduction to the course, Capstone Project of Digital Indigenous Culture Revival and Industry Development, and highlight the students' achievements. I look forward to your valuable feedback. This course is a hands-on, application-focused capstone project centered on digital technology, designed to guide students in creating and implementing innovative projects that promote the revitalization of indigenous cultures or the development of indigenous industries. Drawing on the expertise of multiple educators and industry professionals, the course adopts a collaborative group approach. Through project execution, refinement, and presentation, students gain the opportunity to integrate and apply the knowledge and skills they have previously acquired, turning their learning into practical achievements. The core of this course lies in the creative application of digital technology, covering areas such as digital multimedia, extended reality, AR, VR, big data analysis, artificial intelligence, digital archiving, and e-commerce. Students will learn how to integrate these technologies with the cultural and industrial needs of indigenous communities, designing project outcomes that are both practical and innovative. This approach allows them to further explore the potential of digital technology in cultural preservation and industry promotion. During the course, students engage in group discussions and project-based work, starting from identifying core issues and pain points to proposing solutions and progressively completing their projects. The semester is divided into three main phases. The initial phase involves group formation and assignment of faculty mentors. The middle phase focuses on in-depth discussions and revisions of project concepts, and the final phase culminates in a project presentation. For this presentation, tribal elders, entrepreneurial practitioners, and faculty from the course cluster are invited to participate in the review process, providing students with comprehensive feedback. The course assessment focuses not only on the completion of projects, but also on the understanding of indigenous cultural elements, integration of digital technologies, creativity, and problem-solving abilities. Students are required to submit tangible outcomes, such as research reports or design proposals, and present the feasibility and innovation of their projects through group presentations. This course is not just a learning journey, but also a platform where creativity meets technology. Through hands-on practice, students gain real-world experience in supporting the revitalization of indigenous cultures and promoting indigenous industries. They also enhance their ability to integrate digital technology with humanities, opening new possibilities for their future careers and academic pursuits. The course actively encourages outstanding projects to participate in related competitions, further showcasing students' innovative achievements and creating a broader social impact. This advocacy-oriented micro-video marks the final installment of this capstone course and the concluding piece of our entire credit program. In this final presentation, I plan to share two integrated technologies developed by our faculty and student team during this last semester, serving as the crowning achievement of the Digital Humanities Project at Xuanchuang University. However, for this video, we have once again invited Professor Yuchia Chang to present the details of these two integrated technologies on our behalf.
Hello everyone, I am Professor Yuchia Zhang from the Department of Applied Psychology at Xuanchuang University. I am honored and delighted to be invited by our project leader, Professor Hungwei Li, to present this final micro-video. I will do my best to explain these concepts in the clearest and most detailed way possible, hoping that you will gain the information you need from this presentation. The two integrated technologies I will introduce are virtual avatars and custom GPT. Let's get started. First, I would like to introduce the virtual avatar technology. Throughout our course micro-videos, you may have noticed teachers or students confidently delivering presentations in fluent English, speaking naturally and openly in front of the camera, just like what you are seeing now. However, what you are watching is not actually them in person, but rather their virtual avatars. These avatars are not only highly realistic in appearance and voice, but also exhibit smooth and natural lip movements, blinking, and gestures. So how exactly did we achieve this? The production process for this type of micro video is quite intricate. It begins with determining the storyline and scripting the dialogue. Once the content is finalized, we create virtual avatars for the individuals appearing in the video. This is done using Reallusion's iClone software and its Headshot 2 plugin, which automatically generates a 3D head model from a portrait photo of the instructor or student. Next, we use Character Creator to design unique clothing styles for each avatar and adjust body proportions to match their real-life physique. Once the character models are complete, they are imported into iClone, where we select appropriate stage backgrounds and configure the lighting setup. Only after these steps are completed can we finalize the construction of the characters and their environment. For voice production and synchronization, we first use ChatGPT to translate the Chinese script into English. Then we employ ElevenLabs' voice cloning AI tool to replicate the speaker's vocal characteristics. By inputting the English script into the tool's text-to-speech function, we generate the corresponding audio file. Next, we use iClone's Aculips lip-syncing feature, which maps vSMIS to the waveform and word positions, allowing the virtual character's lip movements to match the spoken content accurately. Finally, we select appropriate facial expressions and body gestures to complete the animation of the speaking sequence. The virtual avatar technology is not only used in our course microvideos, but also in the talking heads featured in our final presentation. The only difference is that the former speaks in English while the latter speaks in Chinese. However, since the current version of Aculips only supports English, generating a virtual avatar speaking Chinese requires an additional workaround. First, the script must be transliterated into Romanized Pinyin and then processed through ElevenLabs to generate the corresponding audio. This audio is then fed into Aculips, where the system aligns the Chinese speech with the Romanized text to produce accurate vSMI and lip-sync results. However, the resulting speech tends to sound somewhat unnatural, resembling a non-native speaker struggling with Chinese pronunciation, which remains a limitation of the current approach. In addition to the virtual avatar technology, another noteworthy integrated technology developed by our team is Custom GPT. However, this was not initially a planned outcome, but rather an unexpected success by our project leader, Professor Hengwei Li. His original goal was simply to find a way to scan physical objects, such as the mascot of the Heping tribe or the intricately crafted wild vegetable paper sculptures. At first glance, the solution seemed straightforward. Attaching a QR code to a physical object would allow users to scan it and access relevant information online. Whether the content was text, images, or even videos, everything could be easily displayed. For a more interactive approach, an NFC tag could be embedded in the object, enabling users to retrieve multimedia introductions simply by bringing their phone close to it. Given these existing technologies, solving the problem of linking physical objects to digital content was relatively simple. However, this problem troubled Professor Li for 2 whole weeks because he felt that even using NFC was somewhat outdated. So he decided to let Gen AI handle the task. The first challenge was figuring out how to make a smartphone recognize an object instantly upon scanning, whether it was the Heping tribe's mascot, Maybelline bear, or various wild vegetables. While Google Lens might be able to identify some common wild vegetables, it certainly wouldn't recognize Maybelline bear. Moreover, integrating Google Lens into the project would require exploring a completely different technological approach, which could demand far more effort and resources than anticipated. Just as he was stuck in this dilemma, Professor Li suddenly thought of ChatGPT's customization feature, GPTs. However, GPTs are fundamentally closer to retrieval augmented generation, RAG, meaning that no matter how many times it is trained to recognize Maybelline bear, it wouldn't actually modify the underlying large language model, LLM. Moreover, GPTs do not have long-term memory. Once the conversation is restarted, all previous knowledge is lost. Of course, deploying a local LLM and gradually training it wasn't a viable option either, as this would be far more complex and unlikely to yield practical results. It seemed that using GPTs wouldn't work after all. But just when it appeared that this approach was a dead end, Professor Lee had a sudden realization and found an alternative way to leverage GPTs to solve the problem. If ChatGPT can interpret images, then it should be able to describe the features it sees. And if it can describe these features, it should also be able to recognize what it's looking at. This internal dialogue was the breakthrough moment for Professor Lee. Since ChatGPT primarily operates through text, he first showed it images of Maybelline Bear and asked it to describe the bear's characteristics. Then he fed these AI-generated textual descriptions into the custom GPT, instructing it that anything matching these descriptions should be identified as Maybelline Bear. The logic worked perfectly. With just a few images and the simple steps mentioned earlier, the Atayal Knowledge Expert Custom GPT was able to correctly recognize and identify Maybelline Bear. Beyond this, since Maybelline Bear holds different objects in its hands, such as Makino bamboo shoots, persimmons, shiitake mushrooms, or a mortar and pestle, Professor Lee took things a step further. He fed the Atayal Knowledge Expert Custom GPT with the research findings and reports our team had produced over the past 2 to 3 years, specifically those related to the Atayal people and the Heping tribe. He then instructed the model that whenever it recognized Maybelline Bear holding one of these agricultural products or tools, it should retrieve relevant information from these reports and incorporate it into its response, making the answers more detailed, informative, and engaging. Following this logic, Professor Lee further trained the Atayal Knowledge Expert to recognize wild vegetables and provide users with extensive knowledge about them. Taking it even further, in collaboration with artisans, our team crafted traditional Atayal clothing representing the 6 major river basins for small figurines. The Atayal Knowledge Expert was then trained to identify these outfits and provide detailed explanations about their cultural significance. This fascinating experiment not only solved the original problem of how to scan a physical object and instantly retrieve relevant information, but it also made the responses more engaging and human-like. Additionally, it deepened Professor Lee's understanding of both the strengths and limitations of custom GPTs. Recognizing the potential of this approach, he felt it was essential to share this integrated technology with everyone, hoping it could inspire further applications and innovations in digital humanities and cultural preservation. And that concludes my explanation of the virtual avatar and custom GPT integrated technologies. I hope this presentation has provided you with valuable insights. I also sincerely welcome your feedback and suggestions. Thank you.